There are only three situations we will encounter. The unknown, or the variable, could be in the numerator, it could be in the denominator, right? So that's when it's the fraction or the ratio, or it could actually be the angle itself, right? And we're going to use the variable theta, which looks like kind of like a zero with a line through it, okay? So it could be up top in the ratio, in the bottom of the ratio, or it can be the angle. Okay, now remember, each word problem that we talk about is going to require us to choose one of the equations, all right? Sine, cosine, or tangent. So each word problem will have one equation. Solve each equation with 3 steps and label your units. All right, that's something I'm going to focus on very heavily. You'll see that as we go over each question. And finally, we are going to use either one of the following equations for each word problem, right? If the diagram has the opposite and hypotenuse in question, then we'll choose sine. If it has adjacent and hypotenuse, we'll choose cosine. And of course, if it involves opposite and adjacent, then we'll use tangent. All right, so guys, let's dive into the first question here. Now, I'm going to just read it through once, but I highly recommend you read your word problems more than once. Read it at least 2 times or more. All right, so situation 1, when the unknown is in the numerator, okay? So that what's going to happen here is, hopefully, after we write and label our diagram, you're going to see that that variable is up top in the ratio. So here it goes. A wire is connected to a telephone pole. The pole is perpendicular to the ground, and the angle made between the ground and the wire is 40 degrees. All right, let's stop there. So I already started to draw my figure here. As you can see, I put my right angle marker because they did tell us the pole is perpendicular to the ground. Ladies and gentlemen, every word problem is going to involve a right triangle. So here we go. This is no different. They also mentioned that the wire makes a 40-degree angle with the ground. All right, so that's why I have it labeled with pole, wire, and ground. All right, so where the wire meets the ground is right here. So I'm going to label that with 40 degrees. Okay, let's go back up and keep reading. If the wire is 30 feet long, stop. I'm going to go right here to the wire, and I'm going to label that with 30 feet. So if the wire is 30 feet long, then how far up the pole does the wire meet? How far up the pole will the wire meet it? So that's where I'm going to put my variable. I'm going to put that here. But we are looking from 40 degrees. Ladies and gentlemen, where is 40 degrees? Right, that's going to be our opposite side. And what type of side is 30 feet? So that's our hypotenuse. We are using the opposite side and the hypotenuse. So now, using SOHCAHTOA, using our acronym, which of these 3 trig functions uses the opposite and the hypotenuse? Right? That's going to be sine. So let's remember, guys, just like we talked about in class, there's going to be 3 steps here. So the first thing I'm going to do is I'm going to draw my general sine equation. Sine of the angle, sine of theta, equals opposite over hypotenuse. Now I'm going to substitute my values. Do we know the angle that we're looking from? Yes, we do. It's 40 degrees. So now I'm going to replace theta with 40 degrees. Next, opposite over hypotenuse. So what is opposite of 40 degrees? That's going to be my x, the unknown, right? And then what is the hypotenuse? That's my 30. Remember, we should get the variable up in the numerator. It is. So here's our first situation. Now, let me zoom in and focus on solving this equation. As discussed in class, right, we're going to put that over 1 and create a proportion. How do we solve a proportion, ladies and gentlemen? We're going to solve a proportion by cross-multiplying. Okay, so now what I'd like to do is I'm going to do 1 times x, which is x, and then I'm going to do 30 times sine of 40. As discussed in class, guys, we're going to put our multiplier, our coefficient, out in front. The only number to the right of sine should be the degrees, the angle. All right, and again, parentheses are optional. Okay, so now, guys, right from here on out, this is just a calculator example right now. So I'm going to head over to Desmos. I'm going to click my gear. I'm going to make sure that I'm not in radians, that I'm in degrees. And what I'm going to do is I'm going to type in 30 sine. I got to click functions, sine 40 degrees. Close up my parentheses, enter. Now we're going to round to the nearest hundredth, right? So that's going to be 19.28. All right, so our final answer is 19.28, and we got to finish with our label. So that's going to be 19.28 feet, since that is how far up the pole the wire meets. Ladies and gentlemen, situation 2 involves an angle of depression. So just be careful. These are going to take us a little while to get used to, but let's read, all right? This should be a situation in which our variable is in the denominator. So a jet is 32,000 feet off of the ground when it begins its approach to the runway. Stop. Let's go label our diagram. Now, just as I zoom in here, I'm going to put 32,000 feet as my height, as my altitude. Now, of course, the altitude can also be labeled here, but we're going to put the altitude right here, as we just described today in class, 32,000 feet, okay? Whether I mark it here, or here, or here, or here, those heights, those altitudes are all the same. Okay, so here's my right triangle. The plane is flying towards the runway. Now, they also told us that it has a 3.5 degree angle of depression. Depression means down. So what we're going to do is label our angle right here. So that's our angle of depression. Now remember, you're looking straight out, right? There's your horizontal line. So looking down from the horizontal is our angle of depression. I'm going to put 3.5 degrees right in there. All right, next, let's figure out what side we're trying to find. Now, they are very specific. Right here, in the horizontal direction, how far is the plane from the runway? So I'm going to use that clue, that key right there, so that I can now put my variable right here. Okay, that is the horizontal direction. That is the distance the plane is from the runway in the horizontal direction, but we just have it up here. So after reading and labeling our diagram, let's figure out what we're going to do here. So I'm taking a look at what we have, and I'm going to ask myself, from the reference angle, from 3.5 degrees, that is the opposite side, okay? And the hypotenuse is on the bottom. That means this side that we're looking for is the adjacent side. So we're using opposite and adjacent. So ladies and gentlemen, which of our three trig functions uses opposite and adjacent, O and A? Right? Well, that's going to be tangent. All right, so let's write our equation. Again, we're going to write our general equation. Tangent of theta equals opposite over adjacent. Now, we're going to go ahead and substitute our values. Do we know the angle? Sure we do, right? It's 3.5 degrees. Be careful, I almost wrote 35 before. 3.5 degrees equals, do we know the opposite side? Yes, we do. It's 32,000 feet. Okay, I'm going to divide that by the adjacent, right? Opposite was 32, adjacent's going to go on the bottom. So the adjacent side is what we're looking for. So I'm going to put my variable in the denominator. So just remember, this is situation number 2, where the variable is on the bottom of the ratio. Now, these type of equations require an extra step. I'm going to show it, but after a couple times of doing this, ladies and gentlemen, you guys are going to start to develop a shortcut. Okay, so here we go. I'm going to do the same as we did in example 1. I'm going to make this a proportion, and I'm going to cross multiply, right? 1 times 32,000 is 32,000. All right, and again, x times tangent of 3.5 degrees. We're going to put that multiplier, put that out as the coefficient. Okay, tangent of 3.5 degrees. Okay, we're almost there. We need to get x alone, but right now x is being multiplied times the tangent of 3.5. So in order to undo multiplication, right, we're going to divide both sides by the tangent of 3.5 degrees. That's going to be gone, leaving us with x, and then this is what we're going to type, in our calculator. All right, so if I had to write my exact answer, it would be x equals 32,000 feet divided by the tangent of 3.5 degrees. Now, let's go get a decimal after typing that into our calculator. 32, 1, 2, 3 zeros, right? 32,000 divided by, now look, it's nice on this calculator. It makes it into a fraction for us. We're going to now type in the tangent. So I open up functions, tangent 3.5 degrees, close it, enter. Now, it's a big number, all right? So let's see, 523, 195. All right, where do we go here? There we go. So 523,000, what was that again? 195.38. Okay, so now I'm going to write my answer here, and it's going to be rounded to the nearest hundredth, and that is 0.38. Now, guys, this is in feet, all right? So it's a large number, but think about why, right? Now, one thing we mentioned in class is, are our answers reasonable? So guys, think about it. This is the number of feet, the number of 1 foot rulers that this plane is from the runway. So I'm okay with this being such a large number. Okay, now before we finally get to our last situation, all right, we need to remember what we talked about in class today. Sometimes we need to backtrack and find the angle. All right, so now if you look at these 3 examples, right, we are given the sine, cosine, and tangent of an angle, right? So we're given the ratio, whether it's in fraction or decimal form. We have to backtrack and find the angle measure, all right? So it tells us up top that we can use our inverse functions. Inverse sine, inverse cosine, inverse tangent. That's how we say them. Now, let's go take a look at part A. All right, I'm just going to zoom way in there. There we go. So I have tangent of some angle, tangent of theta, equals 7/6. Now, guys, as a reminder, we should have our 3 steps, okay? So this is the first one done for us. Now, all we have to do is recognize, what do we do to undo the effect of tangent on theta, right? We want to get rid of tangent, but it's not a number. So what we're going to do is we're going to undo tangent by using its inverse, which will leave us with theta, okay? Now, as we described in class, the way to undo tangent is by using inverse tangent. So this is the only step that we need to show in order to find what theta is. Okay, remember, 3 steps. They did the first one for us. This is what we're typing in our calculator, and now we're going to round to the nearest hundredth. Now, be careful. When we go to function, I don't want to click tangent. That's wrong, so I want to back that out. All right, we want to click now using the inverse tangent. So I got to make sure I see a little negative first power there, and then 7 divided by 6. I'm going to close my parenthesis. Whoops. Remember what we talked about today, guys? Just make sure you tap away from there in order to close your parentheses. I'm going to click enter. Right now, there it is. There's my angle measure. So I'm going to round that to the nearest hundredth, which is going to be 49.40. So that means this angle is 49.40 what? Be careful, guys. I know we were labeling feet and inches and meters, but this is an angle measure, so we're going to label it with degrees. Next, moving on, the sine of theta equals 0.18. Okay, don't forget, this could also be 18/100ths. It could be written as a fraction. But they give it to us in decimal form, and it doesn't matter. We can still solve this using the same method. How do we undo the effect of sine? We're going to use inverse sine. So now I'm going to write theta equals the inverse sine of the ratio of 0.18. And now my third and final step is going to be type it in and round our decimal to the nearest hundredth. So what do we get? Let's go and click functions. Inverse sine. I got to make sure I see the little negative 1 power. Now we'll do 0.18. Close them up. Enter. So that's going to be 10.37. And guys, what is our label? 10.37 what? Good, going to be degrees, okay? Now here we have the cosine of theta equals 0.761. So let's put our 3 steps down. They did the first for us. So now I want to undo cosine. What will we do to undo the effect of cosine? Well, we're going to use the inverse cosine. All right, so I write that down. Theta equals the inverse cosine of 0.761. And now, guys, our last step is going to be, let's use the calculator to give us our angle. Okay, inverse cosine here of 0.761. Close them up, enter. And I'm getting approximately 40.45 degrees. All right, so here's our third and final situation. It's when the unknown is the angle measure. So a ramp is made for access to a storefront. The ramp itself is 12 feet long and the horizontal length is 10 feet. Use this information to find the angle of incline, or AKA the angle of elevation. Round your angle to the nearest hundredth. So guys, we're trying to build this ramp to get to a storefront. So what I wanted you to understand is we should get this right angle on here. So I wanted to show you a more realistic picture before we get to just this kind of general picture here, right? The ramp itself is 12 feet long. Ladies and gentlemen, that means I'm going to put 12 feet right here. That is the length of the ramp, okay? So next, The horizontal length is 10 feet, okay? Horizontal length is 10 feet. I'm going to put that down here because that is the horizontal side length, okay? And then they also want us to find the angle of elevation or angle of incline. An angle of elevation is how many degrees you are looking up from the horizontal, all right? Looking up from the horizontal, so I'm going to put theta there. You can use x degrees if you'd like, but I'm going to continue to use the proper variable, which is theta. Ladies and gentlemen, from theta, be careful. This is the opposite. This is the hypotenuse. This is the adjacent. Which trig function uses adjacent and hypotenuse? And that's going to be the cosine. Cosine of the angle, cosine of theta, equals a over h. Okay? Now, let's go ahead and plug our numbers in. Do we have the angle? In the last two examples, yes. In this example, no. This is what we're trying to find, so that's our variable. And then on the other side, we're going to have what fraction? Well, the adjacent side is 10. The hypotenuse is 12. You can simplify that to 5/6 if you'd like. So how will we undo cosine? We will use inverse cosine. And now what I'd like you to do is please go type that in your calculator. What are we getting for our angle of elevation? 33.56 degrees. All right, so we got a lot done in one day. All right, it's going to take a little while for us to warm up to this, but let's remember a couple quick things. There are only three situations you might encounter. Variable in the numerator, variable in the denominator, variable is the angle. All right, we are always going to choose one of these and show our three steps. Thank you, everybody. I hope this video helps.